Hello and welcome to this video walkthrough of a level 2 probability exam. This is based on the 2020 NCEA exam, but you'll notice that some of the questions are a bit different. The numbers are different too, but hopefully it will give you a good idea of what to expect in the exam and what exam style questions may ask you to do. So as you might expect, we will start with question 1. Owning an EV in New Zealand has become more popular as technology has improved, prices have dropped, and people have become more aware of environmental issues. The questions in this paper relate to research about EVs. Elena finds the results of a survey conducted on staff and students of a New Zealand university. The survey asks about various matters relating to ownership of EVs. 12% of the survey respondents were staff, and the rest were students. 90% of the staff and 32% of the students drove to university. Of the students who drove, 48% said they would like to own an EV, while 75% of the students who did not drive said they would like to own an EV. Find the probability that a randomly chosen respondent in the survey is a staff member who drove to university. Okay, so let's highlight the information we know. 12% were staff and the rest were students. 90% of the staff and 32% of the students drove. And 48% of the students who drove said they would like to own an EV. And 75% of the students who did not drive said they would like to own an EV. So we've got two sets of information here. We have got whether they were staff or students, and we have got whether or not they drove to university. So we want to find the probability that a randomly chosen respondent is a staff member who drove. Well, we know that there's a probability of 0.12 of picking a staff member, and 90% of the staff drove, so we can times that by 0.9, and that will calculate the probability. So the probability staff and drove, so 0.12 times 0.9 is 0.108. The question doesn't specify how they want the answer, so giving it as a decimal is absolutely fine, and that is the answer for the question. So that is an achieved for that question. Find the probability that a randomly chosen respondent in the survey is a student who did not drive to the university and would like to own an EV. It's a student who did not drive and would like to own an EV. So probability of getting a student does not drive to the university and would like to own. Well, the probability of a randomly chosen individual being a student is 0.88, because the probability of them being staff is 0.12. So 1 take away 0.12 is 0.88. The probability of a student not driving, well, 32% of students drove, so that must mean then a 68% chance, or 0.68 chance of them not driving, and they would like to own an EV. So of the students who drove, 48% say they would like to own an EV, while 75% of those who did not drive, that's what we're interested in, said they would. So 0.75. Okay, so 0.88 times 0.68 times 0.75 equals 0.4488. And that is the answer for that question. and that is also an achieved question. So those are the two achieved parts of question 1 done. Let's go on to part 3, which will be a merit question. If a student respondent said they would like to own an EV, what is the probability that they drove to the university? Okay, so I think for this one it's helpful to draw a probability tree. Now, you could have done this for the 2 parts of question A as well, and that would probably be beneficial too. Because they're a bit simpler, you don't need to have it. We did those just fine without, but I think it is beneficial. For this one, a bit more complicated, definitely be beneficial to draw the probability tree. So let's do that. So we're going to start off with our staff and students. So 12%, so 0.12 was staff. The rest were students, so that must be 0.88. 90% of staff and 32% of students drove. So 0.9 drive, which means 0.1 don't drive. And for students, 32%, so 0.32 drive. So 0.68 don't drive. And then of the students who drove, 48% said they would like an EV. Which means 52% or 0.52 don't want an EV, while 75% of the students who did not drive said they would like to own an EV. So 0.75 and then 0.25. So remember that branches that start from the same place have to add, their probabilities have to add up to 1. So that's how I worked those out. Okay, so remember the question is, if a student respondent said they would like to own an EV, what is the probability they drove to university? So we need to consider the outcomes where we have a student who wants to own an EV. So we could have a student who drives and wants an EV, and we could have a student who does not drive, who wants an EV. Those are the 2 possible outcomes where a student wants an EV. So let's work out those probabilities. Because if we add those together, so the probability that they are a student who drives to the university who wants an EV, if we add that to the probability that they're a student who doesn't drive, who wants an EV, that will calculate the probability that a student wants an EV. Okay, so for the orange probabilities, if we just go up and remind ourselves, so we're doing this orange branch, that's, remember, always multiplier going across a probability tree. So we're going to do 0.88 times 0.32 times 0.48. And for the other branch, it will be 0.88 times 0.68 times 0.75. So we'll work out those probabilities. So for the pink branch, it is 0.4488. For the orange branch, it is 0.135168. So if we add those together, we get 0.583968, which is not the final answer, but we are nearly there. So if we want to work out specifically the probability that they drove, so probability a student drove if they want an EV, we divide that orange probability by the total, and that will work out the proportion which is 0.231465, which we can round to 0.2315. For probabilities, it doesn't matter hugely how you round it, but generally 3 to 4 decimal places is fine. So that is the answer. So this is a merit question. For achieved, you have got to calculate either the numerator or denominator correctly. So if we're looking at this fraction down here, either the orange or the black probabilities have to be calculated. And then for merit, arriving at the final answer. Okay, let's go on to part 4. Of the staff who drove to the university, 52% said they would like to own an EV, while only a quarter of the staff who didn't drive to the university would like to own an EV. What percentage of all survey respondents would like to own an EV? So this is going to include staff and students. So we've been given some extra information that we can add to our probability tree. So if we get rid of these, we don't need those anymore. We've been told information for the staff about whether they want an EV or not. So for the staff who drove, 52% said they would like an EV. So 52% want an EV, that must mean 48% don't. Only a quarter of the staff who didn't drive would like to own an EV. So 1/4 is 0.25. Oh, that wasn't very good. Running out of space a little bit, huh? So the question is, what percentage of all survey respondents would like to own an EV? So a bit like we did before, let's circle all of the outcomes where that individual want an EV. So we could have a staff member who drives who wants an EV. We could have a staff member who doesn't drive who wants an EV. And then we can have a student who drives and wants an EV. Or we can have a student who doesn't drive who wants an EV. So those are the 4 outcomes where that individual wants an EV. So we need to work out all those probabilities and then add them together. Now, for the student ones, we've actually already done those. We did those in the previous questions. So let's write out what those probabilities were. So for that orange branch, it was 0.135168. For that pink branch, it was 0.4488.